tutorial is to demonstrate enough of the cadnano interface so that you can start making arbitrary three-dimensional DNA origami shapes. Typically we use M13 derived scaffolds, which are over 7,000 bases long. To keep things simple, I'm just going to build a small 6-helix bundle nanotube. So you'll notice that there are three main panels in the interface, along with a toolbar for saving and loading data, and a dock that can be used to hide or show any of the panels. I'll just jump right in and then stop and explain parts of the interface as I go. I'm going to start by clicking in the left panel and to add 6 helices that I want to work with. The leftmost panel is what we call the slice panel. If in our honeycomb lattice abstraction, the helical axis of each strand runs parallel to the z-axis in 3D space, then the slice panel is a fixed view of the XY plane. So basically you're looking down the ends of the helices. The slice panel is used to choose which helices you want included in your structure. The middle panel is the path panel. Now if the slice panel is a front view, you might think of this as sort of an unrolled side view of your structure. And this is where we spend most of the time routing scaffold and staple paths. The right panel is the 3D panel. And early on I had this idea that providing a real-time 3D interface would make the 2D interfaces more intuitive. So the 3D panel does not actually provide any editing tools for the structure, and you can minimize it and ignore it if you like. Okay, so moving on. Both the slice and path panels have edit, zoom, and move tools. The 3D panel also has a zoom button and a move tool. These work basically as you would expect. The edit tool, which I've already used in the slice panel, is used for interacting with the interface. And then the zoom tool can be used to zoom in closer, or if you shift click to zoom out in both panels. And the move tool is for moving around. And at this point I should also mention that there are keyboard shortcuts which also speed up interacting with the interface. So you can type the key which is listed under each of the tools in the path panel to switch between different tools over here. And you can also use the arrow keys to move around in the path panel. So you spend most of the time over here, so that's what the focus of the keyboard shortcuts are mostly for the path panel. So next I'll explain how the slice and path panels relate to each other, which is actually through what we call the slice bar, which is this thing I'm dragging right here. And the slice panel actually displays and edits information for the currently selected slice in the path panel. So while the honeycomb lattice is always fixed in the XY direction, how the helices are highlighted or edited depends on the location of the slice bar in the path panel. Notice that when the slice bar is moved to the first or the last position, it pops up with a little button that gives you the option to extend the grid in the Z direction. So this is how you expand the editing area in order to make a structure that requires more than just the default 42 base zone that we start with. And the slice panel has buttons to quickly move the slice bar to the first or the last position. So let's just go ahead and make this a little bit larger editing area. So I get this pop-up window and I'm going to extend the grid by 42 bases. We click OK. And we can see that now we have more space to edit with. Okay, so what do we have so far? I have my basic shape worked out in the slice panel, so I can minimize this since I'm not going to do any more editing. And now what are we looking at in the path panel? Basically this is an unrolled schematic view of the scaffold and stapled paths. So each of these little grid squares corresponds to a single base in the structure, and the top row of grid squares in any one of these rows corresponds to bases which are running at 5' to 3' in the positive Z direction, and that would be into the screen looking at the slice panel. And the bottom row of squares in each of these helices is basically it's DNA which is running 5' to 3' in the negative z direction, or that would be or out of the screen in the slice panel. So the two rows of grid squares are base paired with each other in any one of these helices in the DNA origami structure. And right now we only have little bits of discontinuous single-stranded scaffold showing, because when we add a helix in the slice panel, it only adds 3 bases at a time to the path panel. But when we add in all the staples and finish routing all our paths, it should be clear how everything is routed and how everything is base paired with each other. The rectangles represent 5' breakpoints, and the triangles represent 3' breakpoints, and they're both draggable with the mouse. So if I bring back the 3D panel and then start dragging these guys around, we can see that I'm actually extending the helices. And so basically you can start editing the scaffold paths primarily by dragging around breakpoints. And now our goal is actually to choose a continuous route for the scaffold path and then generate a list of staples that will force the scaffold to adopt that configuration in the test tube. So we can extend the scaffold in a few different ways. So like I already showed, we can drag these breakpoints back and forth. We can also option click on the breakpoints in order to send them to their extreme boundary. So if I start clicking on them, option click. And then also I can shift option click on the slice bar, and that will send all of the breakpoints to their extreme boundaries. And that's actually probably the fastest way to quickly move everything to the edges. And the next step is to install scaffold crossovers between neighboring helices. So you'll notice that as I click on different helices, these little numbered icons pop up. And these are actually potential crossover positions between neighboring strands. And these only occur between strands which are actually adjacent in the slice panel. So you can see that 0 is next to 1 and 5 in the slice panel, and actually we have potential crossovers from 0 to 1 and from 0 to 5 and vice versa. So what we're going to do is just click on these little icons and actually start installing crossovers between these helices. So I just click, and now I created some breakpoints for the leftover strand here, and then we actually now have a continuous path of the scaffold from, for example, from strand 0 to strand 1 at this position. So that's actually half of a holiday junction. And then we can go to the other end of the helices and install other crossovers. So maybe I want to make them all identical length, so I'll seal up these nicks and then put a crossover here, here, and then also here. And then what I like to do is just use the erase tool to just click along with the arrow keys to click on the extra strands that I don't need anymore. So I'm just erasing these. All right, so here's our scaffold. And the next thing we're going to do is actually link these together. So we have 3 separate loops. I want to install internal crossovers here. And actually, I would want to put another crossover between helices 3 and 4, but I'm going to leave that out for now. And then we'll go back and add it in later. Okay, next we want to add our staples, and this can be done in 2 different ways. The best way to do it on the first pass is to use the auto staple button over here, and this generates a default set of staples with almost all the possible crossovers installed. So I'll just go ahead and do that and confirm. And now we have a default set of staples. And before I start editing those, I'll just show you the other way to add a staple to the path panel, and that's actually by shift clicking over in the slice panel. So if I just staple strands, just one at a time. But I'll just get rid of those since we don't need them. All right, so the first thing you'll notice about these staples is that some of them are drawn thicker than the standard lines, and other ones look normal. And so there's a difference between normal thin line strands and also the thick or highlighted strands. And the thick staples are highlighted because they're either circular paths or they're outside the recommended size range for the length of a staple, which is between 17 and 50 bases, non-inclusive. So the last thing we want to do is break up our staples so none of them remain highlighted. And this can be done also with the break tool. So I just choose the break tool and then go through and start looking at positions I might want to break these staples. And usually I'll just start at one end of a staple and start counting up. I try and get roughly 42 base staples, but shorter or longer is fine. And so I just start right here, and I do 1, 2, 3, 4. So this is like 28 plus 5 bases. That's fine. And then let's see, 1, 2, 3, 4. Yeah. So I'll break it here. Maybe I'll break the staple here, and then maybe one more break here. And I just work my way, through the paths and break the staples up into smaller pieces until none of them are highlighted anymore. And let's see here. Well, we'll put a break there. And I still have this strand, which it's highlighted because it's too short. And there's really nowhere for us to go, so I might actually just remove these crossovers and then just combine those staples with other staples. And then we have one more down here, and now this guy's too long, so we'll just add a break right there. All right, so now we have our staple paths. None of them are highlighted. And the next thing, if we're happy with the staple arrangement, the last step is going to be to generate our oligo list. And this is done with the add sequence tool, which is down here in the corner. And so the add sequence tool basically applies scaffold sequence starting at a 5' scaffold breakpoint. So when we do this, we'll get a pop-up window which shows us our sequences. And so I'll just go ahead and do this. So you notice that actually clicking here doesn't do anything. We actually have to create a breakpoint. So I'll just create a break right here. And then the add sequence tool actually only works on a 5' end. So I click, I get some choices of what scaffold I want to use. I'll just use the regular M13 scaffold. And then we get the resulting staple list. And the first thing you'll notice here is actually some of these staple sequences have question marks in them. And this is because we actually had a discontinuous scaffold path. If you remember, I left out the crossover between 3 and 4, which we would normally want to put in, just to demonstrate that if you have discontinuous scaffold paths, then those staples will show up as question marks wherever they don't know what sequence they're supposed to be. So we can come back in here and actually install this crossover, and then I'm going to just get rid of that crossover there. Because I don't want to create any topological problems by having only 5 bases between a scaffold and a staple crossover. And then I'll just edit these guys. And all right, that looks good. And now I'll just regenerate that staple list. Click there, use the same scaffold. And now all of our sequences look good. I don't see any question marks. So we can just copy this to the clipboard and then work with our spreadsheet program. Okay, so I'll just go into numbers and paste the sequences into the spreadsheet, and we just see the same information we have here. And then one cool thing that we can do with the spreadsheet is actually use it to group our oligos. we want to pipette them in different groups when we're actually doing a folding experiment. So what we can do is actually just come back in here and use the paint tool, which allows you to change, select the color of each staple, and we can just go through and paint all of the staples specific colors. And so, for example, you might want to have all of the staples on the edge of your structure. You might want to sort of pipette those separately from your core staples. So what I might do is just color those. We'll color the front staples green, and then maybe I'll make the rear staples blue, and then I'll just regenerate the staple sequences using the add sequence tool. So now we just get a different, basically the same staples, just different color assignments. So I'll just copy those back to the clipboard, go back in here, and paste those. And now we see our colors have been overwritten. And what you can go is you can go into the conditional formatting rules and then actually add rules for each of the staples that you want to highlight. So if I say text is red, and then I'll just choose a fill color for that, and now my red staples just show up there, easy to spot. And then maybe I'll just do this for the other ones. 1700DE is blue, and then just the last one, we'll just say text is 007200 is green, and I'll highlight that green. Okay, so now you can just come in here and then sort this column, and then you just easily group your staples. So when you order them, they'll be adjacent in the 96 roll plate, for example, and easy to pipette. And so the last thing I want to show you is just how to export some of our design in some of the different formats. One last thing I wanted to mention about the paint tool is that you can just use the keyboard shortcut P to cycle through the colors quickly if you don't want to go and click in the color picker. So that speeds things up a little bit when you're just picking random colors. I'm gonna save talking about the more advanced editing tools for a future tutorial. The last thing I want to show you is how to export our design in SVG and X3D formats. So if we just click on the SVG export tool, and then I'll just call this a.svg and save it to the desktop. Then I can just open this up in Adobe Illustrator, and I basically have the same thing that I see in the path panel, just in Illustrator. So this is cool for making figures and diagrams, to have a vector format of the structure to just in order to get it out of the program, and so you can resize it, and we can actually also, as you see, the sequences are there. So if you ever really want to look in detail at what bases are in which position, then you can use the SVG export to do that. Finally, we can export a 3D or X3D model of what's in the 3D panel over here. So you just click over the X3D export and just use the default there. And I can open this in the X3D viewer called Instant Player. And so you get sort of a nicer 3D model than we can render currently in using Adobe Air. So this is also cool for quickly making a simplified model of your structure. Okay, so I think that's about all I wanted to cover. I hope you found this tutorial useful. I've really tried to make this interface as simple and intuitive as possible, so DNA origami will be accessible to as many people as possible. Please email me if you have questions or comments or feature requests, or probably most likely is you found a bug and would like the bug fix. So